Question number 6 of exercise 4.5. Integrate x square minus 3 over x into under root x square plus 4. We need to integrate this function x square minus 3 over x into under root x square plus 4 dx. We can separate our denominator below these functions like x square over x into x square plus 4 dx, and then plus integral negative 3 over x into under root x square plus 4 dx. Now we can write it like I1, take this negative sign outside, negative I2. I just name these integrals and separately I can solve them like I1 is equals to here x square over x into under root x square plus 4 dx. That will be equals to x over under root x square plus 4 dx. I will just separately solve them and then I will substitute back in this equation number 1. It will be easier to just solve them separately. Now we know that the denominator, if we take the derivative of this denominator inner function of under root, that is 2x. I can make here 2x by 1 by 2 into 2x like this. Now this under root x square plus 4 can be moved up and its power will become negative 1 by 2 dx. Now this function has the derivative with itself, so it will be power plus 1 divided by that power like this. So it will be equals to 1 by 2 x square plus 4 1 by 2 over 1 by 2. This 1 by 2 and 1 by 2 will be cancelled. So I will get here in my answer x square plus 4 under root. So this is the answer of this first integral. Now consider the second integral, that is I2 equals integration of 3 over x into under root x square plus 4 dx. Now here I am going to use some substitution. And I told you earlier in the exercise 4.5 part 1 that how you are going to choose your substitution if you have some square terms inside your under root. This is here you are going to substitute if you have x square plus a square type function. Then you will substitute x is equals to a tangent theta. Here a is 2. So let x is equals to 2 tangent theta. So dx will be equals to 2 secant square of theta d theta. Now use this substitution in this integral. Your I2 will be equals to 3 over x is 2 tangent theta now. That will be 2 tangent theta under root. X square will be 4 tangent square of theta plus 4 and dx is your 2 secant square of theta d theta. This 2 will be cancelled with this 2. So I will be left with integration of 3 secant square of theta over tangent of theta. Now this integral, this under root, you will take the 4 common, and if I take 4 common, I will be left here 2. Under root 4 will give us 2 here, and inside I will be left with tangent square of theta plus 1 and here d theta. We know that 1 plus tangent square of theta is the secant square of theta. So it can be written as 3 secant square of theta over 2 tangent theta. 1 plus tangent square of theta will give us the secant square of theta, and the under root of secant square theta will give us secant theta like this. Now 1 of the secant theta can be cancelled with this one. So we will be left behind 3 over 2 secant of theta over tangent of theta d theta here. Now our integral I2 is equals to 3 by 2 secant of theta over tangent of theta d theta. Now simplify these terms. We will get 3 over 2 integration of secant theta. Secant theta is basically 1 over cos of theta divided by sine of theta over cos of theta d theta. This cos and cos will be cancelled. So we will be left behind with 3 by 2 integration of 1 over sine of theta d theta. That is equals to 3 by 2 integration of cosecant theta d theta. That is, you know very well that has the formula of integration, that is equals to 3 by 2 ln of cosecant theta minus cot of theta d theta plus c, constant of integration, that I am not writing here. I will write it in the main equation at the end of the answer. Now our question, we started from in the variable x and now it is in the variable theta, so we need to convert it. For that purpose, we know that what we let in the start, we supposed x is equals to 2 tangent theta. Now we know that we can write it like x over 2 is equals to tangent of theta. So from here we can take out the value of secant theta, that is equals to under root 1 plus tangent square of theta. So it will be equals to 1 plus x square over 4 under root. So it will be equals to 4 plus x square under root over 2. So out of the secant theta, I can take out the value of cos of theta. And that cos of theta is basically the reciprocal of this, that is 2 over under root 4 plus x square, like this. So we can take out the value of sine theta now from here. We know that sine of theta equals to under root 1 minus cos square of theta. So that will be equals to under root 1 minus cos square of theta is basically equals to the square of this term. So it will be equals to 4 over 4 plus x square, like this. Now simply simplify this. I will get 4 plus x square minus 4 over 4 plus x square, like this. It will be cancelled, so I will get x over under root 4 plus x square as the answer of sine theta. I can take out the cosecant theta out of it, that will be equals to under root 4 plus x square over x. So that thing I needed here. One more thing that I need is the cot of theta. So you know that cot of theta equals to cos of theta over sine of theta. And what is the answer of cos of theta? This answer. So that will be equals to 2 over under root 4 plus x square divided by sine of theta. And sine of theta is this value, that is x over under root 4 plus x square. If I change this deviant sign into the multiplication, it will just reciproc. So it will become 2 over under root 4 plus x square multiplied by under 4 plus x square over x. This will be cancelled. So the cot of theta will be equals to 2 over x. Just replace the values here. I will get I2 equals to 3 over 2 ln cosecant theta is this value, that is equals to under root 4 plus x square over x minus cot of theta. Cot of theta is 2 over x, this value, this thing. So we can write it like 3 over 2 ln under root 4 plus x square minus 2 over x. So this is the answer of I2. Now I got the value of I1, this thing, and I got the answer of I2 as well. I can substitute back these values in this equation number 1. So I will get from here using, let's write here, using values of I1 and I2 in equation 1. We know that what our equation 1 was, that was x square minus 3 over x into x square plus 4 dx, and that was equals to I1 minus I2. Just replace the values here. The answer for I1 was under root x square plus 4. So I got x here, x square plus 4. Then minus I2, minus this value, negative 3 by 2 ln under root 4 plus x square minus 2 divided by x and plus constant of integration in my answer. So this is the answer for question number 5. Now question number 6, it is under root 3x square minus 4x plus 1. We need to integrate it now. Integration of under root 3x square minus 4x plus 1 dx. Now I want to make here the complete square. For that purpose I need here only x square. So just take 3 common out of it. So I will get here like this. 3 common, so I will get x square minus 4 by 3x plus 1 by 3 here, dx. Now separate this under root 3 and take it outside since it is a constant, so I can take it out. So it will become under root 3 integration of x square minus 4 over 3x plus 1 over 3 dx. Now I can make it by completing square method, under root 3 integration. This thing, it can be written as x whole square. Now I have the negative sign with this x, so I am writing negative 2 and these two brackets. You know that the square formula, that is x square minus 2xy plus y square. So I am making the same format. Now the first thing will come here. Now I need to think about this second term according to this thing. I need to write here some number so that I can get back this negative 4 over 3x. 2 is written already, so what is left here? 2 over 3 is left here. Now I need its square here as well, plus 2 over 3 whole square. If I am writing here plus 2 over 3 whole square, then I need to write here negative 2 over 3 whole square as well. And the rest of the thing plus 1 over 3 will be written as this. Now the first three things is basically the completing square formula, that is x minus 2 over 3 whole square. And the rest of the things, I need to simplify them. These two things, I know that this is, I'm writing here 1 over 3 first and then this negative 4 over 9. I need to take its LCM and I will get here 1 over 9 in my answer. So negative 1 over 9. So it can be written as negative 1 over 3 whole square like this dx. Now this is the format for under root x square minus a square, integration of under root x square minus dx. And this is the direct formula that you need to memorize, integration of under root x square minus a square dx. That will be always equals to your, this is x square minus a square, this will be x into under root x square minus a square over 2 minus a over 2 cos hyperbolic inverse x over a plus c. This is the formula for integration of x square minus a square dx. Now here in place of x you have x minus 2 over 3 and in place of a you have 1 over 3. Just replace the values. I will get here in my answer under root 3. X now is x minus 2 over 3. So it will become x minus 2 over 3 bracket under root this x square minus a square. That is the same thing, this one. So this is x minus 2 over 3 whole square minus 1 over 3 whole square divided by this formula 2 minus a is your 1 over 3 divided by 2 cos hyperbolic inverse x. X here is x minus 2 over 3 over this 1 over 3 and your plus constant of integration here. After simplification, these terms, I will get here under root 3. This will be 3x minus 2, this thing, and this denominator 3 will come down. And you know that how you made it from this integral, this one. It is the same thing, you just moved it, changed it into this. So after opening this, you can open it, but you will get back the same thing, this one, this thing. So just write, you can just replace this under root with this under root. So it will become simply x square minus 4 over 3x plus 1 over 3 divided by 6. And here you will get here what? This in the formula here. In the formula here you have a square. So this is basically your square. So it will become after simplification 1 over 18 cos hyperbolic inverse 3x minus 2 over 1 here, because this 3 and the upper denominator 3 will be cancelled. So you will get this thing in your answer of this question. You can simply multiply this under root 3 inside, but it's up to you, you want to multiply it or not. But this is your answer of this question number 6. In question number 7, integrate under root x square plus 2x plus 3 integration of under root x square plus 2x plus 3 dx. Normally in these kind of integrations, like we did in question number 6 as well, you need to complete square formula here. For that purpose, you're going to make it like this. This is the coefficient of x square is 1 here, so there's no need to take something common. So just complete square. So it will be written as x whole square. Then you see here with the x power 1, you have positive sign here. So the positive sign come here in this formula. And you need to write here 2 always. 2 and these two brackets. Now the first thing will come here, that is x, and write any number here so that you can get back this thing. So you know that you can get back this 2x out of this if you write here 1. Now for completing square formula, you need 1 square here and you need to subtract it as well, and the rest of the thing, that is plus 3, will be written at the end like this. Now the first three things, x square plus 2x into 1 plus 1 square, can be written as x plus 1 whole square like this. And the rest of the thing, negative 1 whole square plus 3, you will get here plus 2 under root dx. You can write it like under root x plus 1 whole square plus under root 2 whole square dx like this. Now you get here some format of a formula, and that is integration of x square plus a square dx. You know that the integration of x square plus a square dx equals, that was the same formula as we used in question number 6, but that was having the negative sign. Due to the negative sign, you were having the negative here, and also you were having the cos hyperbolic inverse. But now it will be replaced by x into under root x square plus a square over 2 plus a square over 2 sine hyperbolic inverse x over a plus c. So just replace this using this formula. Now your x is x plus 1 and your a here is under root 2. So just replace all these values in this formula, substitute it equals to this integration. So you will get here x now is x plus 1 under root x square plus a square, that is x plus 1 whole square plus under root 2 whole square divided by this formula 2, then plus a square by 2, that is under root 2 whole square by 2 sine hyperbolic inverse, that is sine hyperbolic inverse x plus 1 over under root 2 plus c. Now you can simplify it as x plus 1 into under root this thing. You know that how you made it from this in under root. So you can replace it with x square plus 2x plus 3. If you open it, you will get back the same thing over 2 plus from here you will get 2 over 2, and that can be written as 1. So it will be cancelled. So you will be left behind sine hyperbolic inverse x plus 1 over under root 2 plus c. So this is your answer of this question number 7. Now we need to move on question number 8. X over under root 4 plus 3x minus 2x square. Integration of x over under root 4 plus 3x minus 2x square dx equals to, I know that the highest power in the denominator is square and the lowest power in the numerator is x. If I take the derivative of this denominator inside the under root sign, you see that you will get here what? Minus 4x plus 3. I can make the same thing here in the numerator. How? I need here negative 4. So first of all, I need to make negative 4 here. For that purpose, I need to divide it with negative 4 and also multiply it with negative 4. So I will get this thing. Negative 4x over under root 4 plus 3x minus 2x square dx. Now I need plus 3 here. So for that purpose, you need to write here plus 3 and minus 3 as well. Now I can separate my integration into two parts between these two functions. How? I will write it like equals to negative 1 over 4 integration minus 4x plus 3 over this denominator dx, Then minus 1 over 4 integration minus 3 over the same denominator dx. Now since it is the derivative of this function, we can write it like minus 4x plus 3. This can be moved up and the power will become negative. It will be 4 plus 3x minus 2x square negative 1 by 2 dx. Now here this negative and this negative will become plus. So you will get plus 3 over 4 integration of 1 over under root 4 plus 3x minus 2x square dx here. This thing, you know that this thing is the derivative of this function. So in the how we will integrate it, power plus 1 divided by that power. So it will become minus 1 over 4 and here you will get 4 plus 3x minus 2x square power plus 1 divided by with that power. And now here again we will just complete its square. So it will be plus 3 over 4 integration 1 over. Now I need to, we can just take this 2 common outside as well. If I take this 2 common outside, it will be easier for me to solve it. So it will just become under root 2 outside. Inside I will be left behind what? I will be left behind 2 plus 3 over 2x negative x square dx. So that I can get this x square term with the coefficient 1. So that's why I just wrote it like this. Now here you will get minus 1 over 4 plus 3x minus 2x square 1 by 2 over 1 by 2. Plus this under root 2 can be taken outside. It will become 3 over 4 under root 2 like this. 1 over under root, I can take the negative sign common out of here because I know that in the square formulas I don't have the negative sign with the square terms. So if I take the negative sign common, I can write it like 2 minus x square minus 3 by 2x like this dx. Now I can complete its square. This term, how I can write it like x square minus 3 by 2x. This can be written as x whole square minus, due to this negative sign I am writing negative 2, formula negative 2, 2 brackets here. The first term will come here. Now I need to write here something so that I can get here 3 by 2. For that purpose I am going to write 3 by 4. So this and 2 and cancel, and so you can get back this 3 by 2. Now this term will be your b square. This thing, if you are adding it, so you need to subtract it as well like this. So from here I will get x minus 3 by 4 whole square, and this thing is 9 by 16. Now substitute back this thing here. I will get, this will be equals to, after cancellation I will get here negative 1 by 2 under root 4 plus 3x minus 2x square like this, plus 3 over 4 under root 2, and this term integration 1 over 2 minus this minus bracket this thing. I am opening this bracket. It will be 2 minus this thing, x minus 3 by 4 whole square. That minus will become plus 9 over 16, the main under root dx. It will become minus under root 4 plus 3x minus 2x square divided by 2 plus 3 over 4 under root 2, and this thing will become 1 over 9 over 16 plus 2. This thing will become 9 over 16 plus 2. This will give you 41 over 4 negative x minus 3 by 4 whole square, and this main square root dx. Now I need here some square as well, so that I can write it like a square minus x square term. So it will become negative 4 plus 3x minus 2x square divided by 2 plus 3 over 4 under root 2 integration 1 over main under root sign. main under root sign is your this one, and this thing can be written as under root 41 over 2 whole square minus this square term x minus 3 by 4 whole square. We know that this is the thing integration of 1 over a square minus x square under root dx. This has the integration, this term has the integration sine inverse of x over a. So we can write it like this thing will become negative 4 plus 3x minus 2x square over 2 plus 3 over 4 under root 2 sine inverse. What is your x here? That is x minus 3 by 4 divided by this under root 41 over 2. We know that in the formula we have 1 over here a here as well. So 1 over a will become here 1 over under root 41 over 2 as well. So after simplification, we will get here negative 4 plus 3x minus 2x square over 2, and here I will get plus 3 over 4 under root 2 sine inverse 4x minus 3 over under root 41 plus c constant of integration.